everyone. I'm glad to introduce you to Huawei's Agile Campus Network solution. Today, we will learn the free mobility solution. On an enterprise network, different network access policies based on physical ports and IP addresses are deployed on access devices. As enterprise networks become mobile and BYOD technology is widely used, users' physical locations and IP addresses change more frequently. The traditional access control solution can hardly ensure consistency of network access experience. For example, access permissions of users are the same wherever they are. Free mobility is a solution on an Agile network. It enables a user to obtain the same network access policy regardless of the location and IP address of the user. The free mobility solution is used together with switches and the Agile Controller Campus. Administrators only need to deploy unified network access policies on the Agile Controller Campus and then deliver these policies to all associated switches. 1. Policy management breaks down physical isolation. Wired network construction of traditional campuses is based on the following roadmap. Plan stations for each department. Assign VLANs based on access interfaces of access switches. Hosts in different VLANs use specific IP address segments. On switches, routers, and firewalls, service policies are formulated based on IP address. However, the new Office mode has caused two problems. Enterprise's fine-grained division of labor and outsourcing mode that increases in popularity often require that employees from different departments or even different companies work together to complete the same project. These users need to work at the same physical location to improve collaborative work efficiency. However, considering enterprise information asset security, data transmission between employees cannot be enabled in a simple manner. As a result, physical isolation cannot be implemented despite the requirement that users should be isolated. The station planning-based network construction roadmap cannot adapt to the requirement for enterprise information asset security protection. Even though an enterprise has not implemented an open network to which employees can access at any location, enterprise service expansion leads to network upgrade and personnel movement. As a result, currently, station relocation is a common scenario of enterprises. During station relocation, network administrators have to inspect and configure service policies on the live network again. Consequently, administrators' workload becomes rather heavy. 2. Wireless access and mobile office. Traditional campus networks access control measures for wireless access and remote VPN access users are similar to that of wired networks. Different IP addresses are assigned to access terminals to differentiate different types of users. Finally, service policies are configured on network devices based on IP address. The problem of wireless access and remote access is that although these two technologies provide a free mobile office environment for employees, this kind of environment is insecure. Malicious attacks and rogue APs can cause unauthorized users to access the campus network. To solve this problem, user isolation must be performed on wireless networks, and users are required to access the network only after being authenticated. The same user may use IP addresses in multiple scopes to access the campus network. Service policy configuration on the network becomes rather more complex and difficult to manage. 3. BYOD and diversified identities and terminals. Wireless access and VPN remote access extend the campus network's physical scope. However, BYOD solution implementation diversifies the type of users and terminals that access the campus network. If there are only a few types of users on the campus network, traditional dynamic VLAN and dynamic ACL technologies can be used to control access rights of different users. However, after BYOD is introduced, the terminal type, terminal ownership, and access location can be used as dimensions for dividing users. As a result, an enterprise may have dozens or even hundreds of types of users. If traditional dynamic VLAN and dynamic ACL technologies are used, the number of pre-configured VLANs on network devices and that of reserved IP address segments will multiply, increasing network deployment and maintenance difficulty. 4. User hierarchy and QoS guarantee. Functioning as a network security technology, traditional NAC technology focuses on network access rights control based on user identity. Increasing complexity of types of services transmitted by networks drives enterprise employees to pose high requirements on bandwidth and latency. In fact, it is impossible for enterprises to expand their network bandwidth limitlessly, especially enterprise network egress bandwidth, because bandwidth expansion will definitely raise costs. In order to eliminate the contradiction between cost and efficiency, key users must be distinguished from common users, and key services from common services. Traditional QoS distinguishes flows of key services such as voice and multimedia services, requiring low latency from large amounts of common service flows. However, traditional QoS cannot distinguish key users from common users. This is because, to implement a QoS policy, multiple network devices on the path must collaborate with one another, whereas in traditional NAC technology, only authentication point devices can identify user identity. These authentication point devices are usually deployed on enterprise intranets, but not enterprise campus network edges, where bandwidth bottlenecks are most likely to occur. In the traditional solution, static or dynamic VLANs and ACLs are typically used to control users' permissions when their locations change. However, network administrators need to modify configurations constantly when users move. The solution is low efficient and error-prone. In this topology, a user moves from Shanghai to Beijing, and the user's IP address is changed. If we use the free mobility solution, the user will have the same permission to access the web server. Another example, if different users log in from the same terminal, the terminal's IP address is the same, but the user's access permissions are different. Next, let's move on to the detailed configuration procedure of free mobility. We only need to configure VLANs for access and aggregation switches. If 802.1x authentication is used, Layer 2 protocol transparent transmission needs to be configured to transmit EA-POL packets from terminals to core switches. Configure VLANs, IP addresses, and basic routes on core switches. Configure XMPP used for authentication and free mobility. WLAN also needs to be configured to enable wireless access. On the Agile controller campus, the administrator needs to add authentication devices and configure MAC authenticated accounts, security groups, authorization, and free mobility. First, log in to the access switch and configure VLANs for APs and users respectively. If 802.1x authentication is used, Layer 2 protocol transparent transmission needs to be configured. Here, the two access switches are distinguished from each other based only on their user VLANs. The aggregation switches function as Layer 2 devices with a similar configuration to that of access switches. Next, we move on to the configuration of core switches. Configure VLANs for APs and users and create an address pool to assign IP addresses to APs and users. Create a radius profile on which the shared key must be configured the same as that on the Agile controller campus. Configure XMPP with the address being the IP address of the Agile controller campus. Ensure the XMPP password on the core switch must be the same as that on the Agile controller campus. Then configure AAA and radius authentication and accounting. Create a domain and add the configured radius profile and authentication and accounting schemes. Create a free rule profile. If APs can access the network without being authenticated, add their VLANs to the profile. Create an authentication profile named Huawei for 802.1x authentication and MAC authentication and bind the profile to ports that need to enable authentication. Wireless users access the network using portal authentication. Therefore, relevant parameters must be configured. Configure a web profile, bind it to the portal profile, and bind the portal profile to the authentication profile. Next, we start WLAN-related configurations. First, configure the source IP address of the CAPWAP tunnel. Then enter the WLAN view to set the AP authentication mode to No Authentication. Finally, configure the SSID and VAP profiles using portal authentication. Now we have completed configurations on devices. Now let's configure the Agile Controller Campus. Add devices with IP addresses being the management address of the core switch. Enable radius and portal authentication and ensure the key is configured the same as that on the switch. Particularly in portal authentication, configure the access terminal IP list, which contains IP network segments in the planned user VLANs. Configure XMPP parameters, which should be the same as that configured on the core switch. If the AP needs to be MAC authenticated, add its MAC address to the Agile Controller Campus. Then, configure authorization rules. If the rules match these MAC addresses, APs are allowed to access the Agile Controller Campus. The next step is to create the username Jack and password WILL for 802.1x and portal authentication. Create security groups named Employee, Guest, and Web Server, respectively. Configure authorization rules. The user Jack belongs to the Employee security group and the user Will belongs to the Guest security group. Finally, configure permission control policies for free mobility. That is, the employee group can access the web server group, but the guest group cannot access the web server group. Deliver these policies globally. When users go online after being authenticated, they can check corresponding entries on the switch. When they access the web server group using the login terminal, they will find that the configured free mobility policy has taken effect. Now, let's see the detailed operations for configuring free mobility. First, log into an access switch, create VLAN 10 as the AP's management VLAN and VLANs 11 and 31 as user VLANs. Enable Layer 2 transparent transmission on interfaces so that packets from certain VLANs can pass through these interfaces. Then, log into an aggregation switch and perform configuration similar to that on the access switch. The aggregation switch is not a must role in actual networking. After configuring access and aggregation switches, configure a core switch. There are many configurations on the core switch, which include VLAN, IP address, radius, XMPP, AAA, portal, and WLAN. First, create a VLAN 10 as the AP's management VLAN and VLANs 11 and 31 as user VLANs. Create an IP address pool to assign IP addresses to APs and users. Then, configure a radius profile and set the IP address to the radius server's IP address. Set the shared key to the same as that on the radius server and set the authentication port to 1812 and the accounting port to 1813. Configure XMPP with the IP address set to the Agile Controller Campus's IP address. The password must be the same as that configured on the Agile Controller Campus. Next, configure 802.1x and MAC address authentication. Enter the AAA view and create radius authentication and accounting schemes. Create a domain. Add the authentication and accounting schemes and bind the domain to the radius profile. If MAC address authentication is not required for APs, configure a free rule to allow packets from the management VLAN, that is VLAN 10, to pass through. Then, create an authentication profile. Bind 802.1x and MAC address authentication profiles, and also bind the free rule and domain. Apply the authentication profile on an interface so that authentication will be triggered on this interface for access users. Next, configure portal authentication for wireless users. Create a web profile with the IP address set to the Agile Controller Campus's IP address and the port number to 50200. The URL format must be the same as the original one. The shared key must be the same as that used in portal authentication on the Agile Controller Campus. Finally, we start WLAN-related configurations. Configure the source IP address of the CapWAP tunnel. Enter the WLAN view and set the AP authentication mode to non-authentication. Configure SSIDs, VAP profiles, and portal authentication. Up to now, we have completed configurations on devices. Next, we need to perform configurations on the Agile Controller Campus. Open a browser and log into the Agile Controller Campus. Step 1. Add devices. Choose Resource, Device, Device Management, and set device IP address to the management address of the core switch. Click Enable Radius and Enable Portal, and configure corresponding keys. Enter the IP network segment of terminals in the Access Terminal list. Click XMPP and enter the password. Use default values of other parameters. Step 2. Configure MAC address and authentication for APs. Choose Resource, Terminal, Terminal List, create a device group named AP, and add AP's MAC addresses to the group. Choose Policy, Permission Control, Authentication and Authorization, Authorization Rule, and create an authorization rule. Set the service type to MAC Bypass Authentication, Terminal Group to AP, and Authorization Result to Permit Access. Click OK. Step 3. Create user accounts and configure Portal or 802.1x authentication. Click Resource, User, User Management, and create two users, Jack and Will. Step 4. Create security groups. Choose Policy, Security Group, Dynamic Security Group Management, and create two security groups named Employee and Guest. Click Static Security Group Management and create a static security group named Web Server, which needs to be bound to an IP address. Step 5. Configure fast authorization. After users are authenticated successfully, they can obtain permissions of certain security groups. Choose Policy, Permission Control, Quick Authorization. Select Jack and add it to the Employee group. Select Will and add it to the Guest group. After users are authenticated successfully, security groups will be delivered accordingly. Step 6. Configure free mobility policies. Choose Policy, Free Mobility, Policy Configuration, Permission Control. Click Add, and add access policies to allow the employee group to access the web server group, while denying access from the guest group to the web server group. Click Global Deployment. Up to now, we have completed configurations on the Agile Controller Campus. Step 7. Let's enable the Wi-Fi function on an STA and connect to the SSID Agile SH as the user will. The user will cannot access the web server group. Then deregister the account will and log in as the user Jack. The access to the web server group succeeds. Disconnect the STA from the Wi-Fi network and connect the STA to the SSID Agile BJ. The STA's IP address changes. Use the account will for login, and the access to the web server group fails. Deregister the account will and log in as the user Jack. The access to the web server group succeeds. This proves that after the free mobility solution is used, users' access permissions can keep unchanged when they are in different places.